M2 is 3 kilogram, M1 is 5 kilogram. You want to find the contact force between M1 and M2. So again, if you consider M2, you draw a free body diagram for M2. That in horizontal direction, you have a force F acting on it, and contact force M1 pushes back on M2, Fc this way. And you have, of course, M2G and normal force for 2, I can say. And you take this x direction and y direction. You have free body diagram, and your acceleration is this way. As a guide, you know that if you apply the force this way, the acceleration of the object will be this way, right? So if you're considering M2, the acceleration will be this way. And now, if you say sum of Fy equal to MAy, Ay is 0, so it just gives you M2 and M2G are the same. So that's not very useful. But in the x direction, you can say sum of Fx equal to Max, and sum of Fx means F minus Fc, because Fc is in negative x direction, equal to M times A, which is x component of the acceleration, which is the same as magnitude. And then you know F and M2 and acceleration. So you can't solve this because you don't know acceleration, you don't know Fc. So that's one equation, two unknowns. Then you do the same thing for M1. And again, M1G is downward. Normal force on 1 is upward. And the only force in horizontal direction that acts on M1 is the force that M2 acts on M1, applies on M1. F contact force, this reaction of this contact force applies back on M1. Of course, this is the same magnitude. I may want to put and make it shorter to say that the same force applies in here. The same magnitude but in the opposite direction. And now sum of Fx equal to 0 to Ma gives me this. The only force in x direction is Fc equal to M1 times A. The accelerations are also the same. And this gives me this equation. Again, adding the two equations cancels Fc and gives me the acceleration. So adding F minus Fc plus Fc, that's the total force, external force, equal to M2A plus M1A. I can factor A and say M1 plus M2 times A. Again, you can see that net external force is equal to total mass times acceleration. If you were experienced enough, you could write that from the beginning. The net external force accelerates both of the objects at the same time. So you can get the acceleration. So acceleration, therefore, is the force divided by M1 plus M2. The force is 20 Newton. And M1 and M2 are 5 plus 3 kilograms. That's 20 divided by 8. You get 2.5 meters per second squared, right? So that's the acceleration of each one. Now you want to find contact force. You can use this simpler equation. So Fc equals to 5 kilograms times 2.5 meters per second squared. So contact force is 12.5 Newton, kilogram meters per second squared, Newton. Right? So you see that applying Newton's law to each one separately and adding them together, it gives you the Newton's law for the whole system. net external force equal to m1 plus m2 times acceleration. And then that gives you the acceleration without involving the contact force. And then you see that for the m1, the only force that is accelerating m1 is the contact force. So you can say Fc is equal to m1 times a. Contact force is equal to m1 times the acceleration that you just found. It becomes 12.5. Now, if the force applies the other way around, in case B, when the force applies, case B, the force applies to the M1. So you have this M1 and M2, and the force applies this way on frictionless surface. So you can say that again the net force is equal to total mass times acceleration. So the acceleration is the same because it doesn't matter whether you apply this way or that way. And then in this case, M2 is accelerated by the contact force. The only force acting on M2 is the contact force in horizontal direction. So you can say contact force is equal to M2 times the acceleration, which is 3 kilograms times the 2.5 meters per second squared. So Fc is 7.5 meters per second squared. So the contact force depends on whether the external force applies this way or that way. Any questions? Yes?
Why is the first FC in newtons and the second FC in meters per second squared?
That's because mistake. Newton. Thank you.